Check your understanding 8.7, page 374. How high above the bottom of its arc is the particle in the simple pendulum above when its speed is 0.81 ms? So this is the figure. Natay length na 1 m and then the angle 30 degrees. Natay point P, which is the lowest point in this arc. The first solution is pangitan na to ang value sa V. Unsa man ang V? So we call this the instantaneous particle speed at point P. Mani ang V. Atong isulat ang energy balance equation, which is initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy. So since ang initial kinetic energy is 0, so we expect nga final potential energy is 0 pod. So cancel out sila duha. Then the remaining is initial potential energy equals final kinetic energy. PE, ang iyahang value is ang di bali iya equivalent is gravitational potential energy equals mgh. So mgh equals kinetic energy is equals to 1/2 m v squared. So copy, then cancel out the letter m of both sides, then gh, then 1/2 v squared, then multiply both sides by 1/2, so we get v squared equals 1/2 times gh. Since v squared, we're going to use the square root of 2gh para mawala ang exponent. So money ang ato ang gamiton niya formula. Since ang atong value sa g is equals 9.8 meter per second squared, so ang ato pod value sa h is 1m minus 1m cosine 30 degree. So from this formula ato nang i-substitute, no? Copy the 2, then substitute the value of g, which is 9.8 meter per second squared, then the value of h, 1m minus 1m cosine 30 degrees, then manipulate, then the value of v is equals to 1.6 meter per second. So 1.6 meter per second, this is how fast the mass is moving when it's at its lowest point P. Value sa D, which is vertical. This is the vertical upward displacement of the particle of point P. So ato gyapon isulat ang energy balance equation, which is initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy. So cancel out na to ang initial potential energy, which is ang iyahang value is 0. Then the remaining is initial kinetic energy equals final kinetic energy plus final potential energy. So we know that kinetic energy is equals to 1/2 mv squared equals kinetic energy 1/2 mv d squared na. Kaya atong gipangita is ang d man, value of d. Nanay md squared plus the value of PE equals mgh. So dili na mgh kaya di man itong gipangita ang vertical upward displacement. So maong mgd ato igamit d. So atong i-cancel out from both sides na may m common. So cancel out, then we get this formula. Mano siya. Then substitute ang v squared. Ang v na to is 1.6 meter per second. So substitute 1.6 meter per second squared minus v d squared. Ang iyahang value is 0.81 meter per second. So substitute lang. Then we get the 33.3 centimeter. Mano ang atong d, value sa d, 3.3 centimeter. This is the vertical displacement of the mass above point P. Dire. Example 8.8, page 375. Air resistance on a falling object. A helicopter is hovering at an altitude of 1 kilometer when a panel from its underside breaks loose and plummets to the ground. The mass of the panel is 15 kilograms. and it hits the ground with a speed of 45 meters per second. How much mechanical energy was dissipated by air resistance during the panel's descent? So this is the diagram. Panel falls from this height, then the terminal velocity. Mani ang graph from this height, ang iyang E and U is same sila. Then K is equals to 0. About diri sa terminal velocity, magka-decrease ang iyahang E, mag-decrease, and also ang U, mag-decrease gyapon. Then ang K is constant. Magpabiling na siya, dili siya ma-decrease, dili siya mo-increase. Constant siya. Strategy, isa ra gyud ka body ang atong imbestigahan, which is kanina. Then ang gravitational force niya naa sa panel, kani acting on the panel niya. Apil na gyapon ang air resistance, kay magkaanam siya kaubos, di bali nagyapoy masugat niya nga air resistance. Apil gyapon ang air resistance, which is stated gyapon diri sa problem. Gravitational force is conservative. So however, ang non-conservative force, air resistance, negative work on the falling panel. Makagamit ta sa conservation of mechanical energy to find energy dissipated. So ang atong formula, this is the formula. Solution: ang mechanical energy dissipated by air resistance is siya algebraic sum of the gain sa kinetic energy and loss in potential energy. Gain siya sa kinetic energy and loss sa potential energy. So therefore, mo atong gamit nga formula, substitute man siya. Then aton na arrive ang answer 130 kilojoules. Example 9.3, page 406. Mr. Sulu, take us out ahead 1/4 impulse. With this command, Captain Kirk of the Starship Enterprise has his ship start from rest to a final speed of final velocity equals 1/4 times 3.0 times 10 to the power of 8 meter per second. Assuming this maneuver is completed in 60 seconds, what average force did the impulse engines apply to the ship? Solution: tungod kay ang problem involved of only one direction. Example, direction sa force nga gi-apply sa engine. We only need the scalar form para sa impulse momentum theorem. Delta P equals J, then delta P equals M delta V. G equals F delta T, then F delta T equals M delta V. Solving para sa magnitude sa force, then ato din i-insert ang given values, ato din ma-arrive ang 2.5 times 10 to the power of 15 N. Example 9.9, page 400 to 403. The Arizona meteor crater. Approximately 50 years ago, a large radius of 25 m iron-nickel meteorite collided with Earth at an estimated speed of 1.28 times 10 to the power of 4 meter per second in what is now the northern Arizona desert in the United States. The impact produced a crater that is still visible today. It is the approximately 1,200 m, 3/4 of a mile in diameter, 170 m deep, and has a rim that rises 45 m above the surrounding desert plain. Iron-nickel meteorites typically have a density of P equals 7,970 kilograms per meter cube. Use impulse consideration to estimate the average force and the maximum force that is meteor applied to Earth during the impact. Ang diagram. Solution. Initial velocity equals initial velocity g. Then f of t equals positive f of t g. T is equal to 0. Then g is equals to mv. So we have average force equals mv over t. So ang mass is equal to the product sa meteor's density and its volume. So m equals p times v. Itong i-assume nga ang meteor was roughly spherical. So we have v equals 4 over 3 pi r cube. Maka-obtain ta og kani nga formula. Problem says ang velocity at impact is equals to negative 1.2810 to the power of 4 meter per second g. Ang iyang final velocity is 0. We guess that the primary impact lasted about t max equals 2s. So ato lang i-substitute these values. Then this is the average force applied during the collision. Notice that this force vector points in the same direction, no, as the change of velocity vector. Kini siya. Next, calculate the maximum force. The impulse is related sa force function by kani nga formula. So we need to make a reasonable choice para sa force as a function of time. So we define t is equal to 0. Sa moment nga ang meteor first touches sa ground, ato din i-assume nga ang force is maximum siya sa pag-impact and rapidly drops to 0. Paspas po siya nga ni drops ta sa padong sa 0. So a function thus mo ni siya. Kani siya nga symbol is mo ni ang parameter nga nagrepresents how rapidly ang force ni decrease to 0. So the average force, so mo ni siya ang para sa average force where ang t is equals to t max minus 0s. Since naanatay numeric value for average force, atong magamit ang result sa integral para maka-obtain ta og f of max. Choosing kani nga formula, naa din ta t of max equals 2s. So this integral evaluates to average force equals 0.458 f max. So ang maximum force na siya magnitude 0.458 f of max equals 3.33 10 to the power of 12 n, and f of max equals 7.27 10 to the power of 12 n. So ang complete force function siya including direction mo ni including direction. By Newton's third law, ang force sa meteor applied to Earth is mo siya na equation which is the answer sa original nga question.